Good afternoon, everybody. Thank you very much to ACI for that much-needed coffee break and nature break. I hope you took your opportunity to do so. Please go ahead and get seated. We're going to get back in gear here. There's a lot more to talk about, and I particularly want to leave time for your questions, because I know you have them. Several of you approached me at the break, so I appreciate that they're going to stick around so that they can all answer your questions. So now we're going to go boom, and we're going to listen to boom. So we have part of the upper airspace, of course, is sort of like bringing the Concorde back in a way cool way. I think we all miss it. I was personally at the Paris airport, Charles de Gaulle, the day that they retired the Concorde, and you can't believe how many people were crying. It was such a sad thing. So I really appreciate the enthusiasm from the supersonic and hypersonic industry, and Boom is here representing them. So let me promote Eli Dourado, like everyone else. He's the head of global policy and communications for Boom Supersonic, so I think that will make you vice president for the day?
Sure.
Will that work?
Yeah.
Okay, so Eli, over to you, vice president of Boom.
Thanks, Nancy, and good afternoon, everybody. I'm delighted to be here with you all today at this important symposium and on this exciting panel. Clicker, there we go. So in 1976, you could fly from New York to London in 3.5 hours. Today, over 40 years later, that same flight is about twice as long. The Concorde was designed on paper, built with aluminum, and powered by turbojet engines. Now we have computational fluid dynamics, carbon fiber composites, and efficient turbofan engines. We have seen measurable progress in almost every area of human achievement, yet somehow flights today take the same amount of time they took in the 1950s. We can do better. Over long distances, people don't think in miles and kilometers. They think in hours. Crossing the US takes about 5. Going from New York to Dubai takes about 14. Speed isn't about going really fast. It's about closeness. It's about making faraway places feel like they're right around the corner. If we can fly twice as fast, the world becomes twice as small, turning far-off lands into familiar neighbors. There are 0 scientific barriers, 0, to supersonic flight. Why take on such a big challenge? Because faster flight brings the world together, as Nancy said. It spreads culture, strengthens bonds, and makes the world a more accessible home for us all. Think about the families separated by these flights. Think about the trips not taken, because when you add up the flights, jet lag, and time zones, the trip just doesn't feel worth it. That's where we come in. We're a team of engineers and technologists brought together for the sole purpose of making our world dramatically more accessible. Our team has made key contributions to over 40 air and spacecraft. We come from Boeing, NASA, Lockheed, and SpaceX. We're the only supersonic program funded through First Flight. We're going to turn 14-hour flights into 6-hour flights at Mach 2.2 with proven science and technology. Flying twice as fast allows airlines to get the same job done with half the planes. Supersonic offers a clear differentiation where today mood lighting is billed as a big upgrade. Our XB-1 demonstrator will roll out at the end of 2018. It will be the first independently developed supersonic jet and the world's fastest civil aircraft. From there, we will begin work on our 55-seat airliner. At 60,000 feet, passengers will be able to take in the curvature of the Earth in a deeper blue sky. You won't have to be on a Forbes list to fly supersonic either. Flying at Mach 2.2 will cost about the same as business class. Ultimately, supersonic will be available at economy fares. The jet age started in the 1950s, and we're still in it, almost 70 years later. That ends with us. Our goal is to get people from point A to point B as quickly and efficiently as possible. No special equipment is needed to fly with Boom. We use no afterburners. We will climb subsonically to 35,000 feet in order not to interfere with today's slow, painfully slow subsonic traffic. Once we get above the subsonic traffic, we will accelerate to Mach 2.2 and climb to our initial cruising altitude of 55,000 feet. And over the course of our cruise, we'll gradually go higher to maintain optimal aerodynamics as our fuel burn reduces weight. We'll come down the same way we went up at subsonic speeds below 35,000 feet. Then we will land mostly in the usual manner, instrument landing, with one difference being that we will prefer a steeper glide slope at airports that have GLS enabled and are willing to support a steeper glide slope. A steeper approach has huge benefits for engine throttle and for ultimately for noise. So it's about 15 decibels of noise savings, which is pretty significant. So hope everyone can support that. Our first airliner will cruise at Mach 2.2 and be certified up to 60,000 feet. But in the future, we want to go faster. And as we go faster to Mach 3 and beyond, we will need to fly higher into the upper E airspace. We recognize that we will be sharing the upper E airspace with the many operators that you have seen today, with very different flight profiles. And we are optimistic about our ability to coordinate with these other users under a very light regulatory framework. I just want to stress, we are not a fighter jet. We are not highly maneuverable, and this is an image of what we don't want. So at speeds above Mach 2, it's smart to have a high degree of separation from other aircraft. But again, I think we can work together to maintain sort of a prudent level of separation with these other players in this airspace. We made a video to share with you why we care so much about our mission, and I hope you enjoy it.
The pursuit of speed is often relegated to the adrenaline seekers, the risk takers, the record breakers. But our pursuit of speed is about something greater. It's speed in service of the experiences that make life precious. Imagine, if you will, flying across the Atlantic, doing business, and being home in time to tuck your children into bed, or where New Zealand becomes as accessible as New York. What would that do for families, for culture, for business? The technology for supersonic flight has existed for over 50 years.
This is the new supersonic airline.
But it was too expensive for routine travel. At Boom, we are refining it, perfecting it, so that high-speed travel can be available to anyone. In the digital age, there really is no more distance. There is only time. Time from one another. Our mission is to remove that barrier, meaning more meetings in a day and more nights with loved ones. Where children grow up with their parents at home, and where relationships are no longer considered long distance. We see New York to London in 3 hours instead of 7. San Francisco to Tokyo in 5 hours instead of 11. We see world leaders spending more time in the same room, the acceptance of cultures, and the spreading of ideas. At Boom, we see the time saved as really the least important part. This isn't about time saved. It's about life gained. Together, we can make cities into neighborhoods and make the world a smaller place. Boom. The future is supersonic.
So I tear up a little bit every time I watch that, so it's okay to cry. I'll give you a moment. But anyway, that's all I have. So thank you very much for your attention, and I look forward to participating in the discussion.
We'll do the dance. There's so many up here, but I want them to all be here to answer your questions. So thank you for that, Eli. Yeah, I teared up a little bit too myself. So now we're going to go into the perspective from a regulatory point of view in two ways. First of all, let me just say that I've not given them much time to think about this, which sometimes is a good thing. So the next speaker is going to be Dr. Liu Hao, and in Chinese you say the last name first, so it's Dr. Lu Hao. His first name is Hao. And he's from Beihang University. He's the chairman. Today you're going to be the chairman, okay? If you don't mind. Today he's the chairman of the university. He's active in ICAO in a number of different venues, particularly in the RPAS panel and the UAV community, and also in an organization called JARUS, which is trying to help harmonize standards for UAVs around the world. And then beyond that, we're going to listen to Henk Hoff. Henk is from EUROCONTROL. So I asked Dr. Lu to give us his perspective. He's a lawyer in addition to being the chairman. I asked him to give us his perspective on the legal framework that would surround this particular sector and his personal views on that, what may need to be done. Henk is going to talk about EUROCONTROL's concept, very early days. I only give him about 30 days to think about this. Again, doesn't always work to your advantage, but I think in this case it may. So we're looking for a light touch from a regulatory point of view. So Henk is going to give us his view. And then Dan Williams from the FAA is going to give you the view from the FAA. He's been working with NASA. He had a little more time, maybe 6 months or so. No, he says no. Okay, maybe NASA had a little more time. Dan didn't quite have so much time. But he's had a little bit of time to work on a concept of operation, and they're going to share their views with you as part of the regulatory community. So Dr. Lu, you first. Over to you.
Thank you. Okay, please write down these 3 words in your notebook or type in your laptop, because this will probably be the new legal regime in the future. Today will probably be the creation of a new legal regime, EUS, Exclusive Utilization Space. We have heard about exciting new operations, but we have to think about it. No regulation, no business. We need regulations, but whether the law are clear enough, I will examine one by one together with you. First, the biggest question is whether the airspace or the space above FL 600, the legal status is clear or not. It is territory airspace of an undernized country, or it is the beginning of the space, especially when we go near the 100 kilometers. For the applicable law, we apply air law or space law, the Space Convention or the Chicago Convention. Secondly, whether the operator have the freedom to overfly or deploy their high-altitude platform over the territory of the exclusive economic zone or the high sea. Not clear. And if you are providing the commercial service, whether you need a license from the undernized country. Can you give me a clear answer? Or whether we have some country have such legislation? Yes, we have. New Zealand. Just come into force from July the 1st. They have one chapter to talk about this. And the national security concern, how could you reduce or satisfy the national security concern of an undernized country, and also the public privacy concern? Last, but also quite interesting, the liability. Not only the liability to the third party, to the aircraft fly in the air, but also, since you are going provide like the internet connection service, we have to also think about the liability to the user of your service. This is unbalanced. We gave too much burden to the safety, security, privacy, and sovereignty. The space for the development, for the innovation, is not enough. Sovereignty is important. In the Chicago Convention, we say that each country share the complete, and we follow the Paris Convention. We reinterpret and even gave more strong emphasis on the sovereignty. But is sovereignty such important? Can we find a way to balance the sovereignty, the privacy, the security, and also the development, the innovation. We have air law, we have space law, but if we put them together, the traditional air and space law meet the new operation. They are not matching. When we don't have a clear answer, we need to look backward. We need to look back into the history. Probably the history could give us some inspiration. When our French colleagues fly their balloons, we have talked about so many balloons today, and our American colleagues test their airplane. We don't have a Chicago Convention. We don't have aviation law. We don't have the International Civil Aviation Organization. When the Sputnik was launched into the space, we don't have any space treaty or the UN copies. So the new operation is always ahead of the law. So be supportive to the new operation. Try to find a way. Or we could also get some inspiration from the sea, because according to my understanding, the sea is always the mother of the air for the rule-making part. If we look into the law of the sea, we may find during old days, we only have a territory sea and a high sea. But with the socio-economic science technology development now, according to the UN Convention on the Law of the Sea, we have exclusive economic zone, we have continental shelf, we have international seabed, and some other legal regime. Today, I would like try to transplant one legal regime in the law of the sea, that is exclusive economic zone. So we created exclusive utilization space. You may vary the scope of the space. Today, I'm just trying to say that such parts of space will start from 20 kilometers to 100 kilometers. We have one drafted paper and the report there. We have 12 characters of the EUS, but today I only want to mention 3. First, the EUS only have a connection with economic use of the EUS. So no country, even an undernized country, cannot declare sovereignty to the EUS. And for the establishment of the EUS, we need consent of the undernized country. So we cannot force one country to establish the EUS. In such way, probably we may find the balance between the sovereignty, innovation, and especially for the international operation. According to our understanding, at least the EUS clarify the legal status of the near space, promote the optimal and orderly exploration of the near space, and will achieve public order to the human dignity. So the EUS will probably be helpful as a legal regime to balance the interest on the two sides. So in the conclusion, the EUS provided a minimum level of legal certainty, a structure capable of promoting progress in the utilization of largely unused near space and maximize the utilization and the social benefits. How could we achieve, how could we establish the EUS? The best way, I think, will be with the ICAO as a forum to discuss, to work on it through the multilateral negotiation. But this is quite hard. If we cannot achieve through a multilateral channel, we may also think about the regional, bilateral, or trilateral. Probably if one country want to start earlier, like we have Kazakhstan, we have Australia, we have New Zealand. No, not New Zealand. We have 3 countries that have declared the top boundary of their airspace at 100 kilometers. we could still choose the unilateral solution. One country, if they think that is clear enough, they want to attract new operation above their territory, they may declare the EUS unilaterally. So I would like to invite you to think about, especially our colleagues from industry, whether this EUS will be helpful for your new operation. Nancy, should I also mention this part? Please. Okay. This is a homework I got from Nancy, the operation of Near Space in China. This is one of the airship which was manufactured, operated by one team, which was based on our teaching and research staff from Beihang University. Now they set up their new company, that is the Beijing Infinite Space Technology Company. They have several successful experiments launching operation already, not just in the conceptual part. They have several successful operation, and according to my phone conversation with them today in the morning, they will have several operations this year. They were providing the smart city service, smart railway transportation surveillance or inspection service, and smart ocean to inspect, tracking, identify the ships or the other vehicles. And they will also providing help for the border patrol or inspection. So remember, EUS, this will probably be the new beginning of international law. Thank you.
Okay. Thanks very much. Wow, that's some new thinking, huh? And thank you for doing the homework. Last evening we talked about this presentation and I said, can you share a little bit about the craft they're operating in China as well? And not only did he get the goods, but he got the pictures. So double score. So Henk, you're up next. Going to talk about the European perspective on this, recognizing that I didn't give him much time. So be gentle with him. Henk, over to you.
Thanks, Nancy. Good afternoon, everyone. Yeah, 30 days ago I was pulled in this adventure by Nancy. And if you receive a question from Nancy, there are two possible answers, yes and yes. So here I am. So by no means this is a European position or European proposals. These are thoughts and ideas. It takes a bit longer in Europe to come to a position than 30 days. So I want to talk with you about this future, and this is just one slide to show a picture of the future, which is not really a future as we have heard. It's a present, and it's a present that develops much faster than we have stepped through the past. So it's something we need to react upon, and we need to make sure that we can accommodate all these possible developments. One development we have not spoken explicitly about, which I do want to mention, which should not be forgotten in this context as well, is the top left. I think, yeah, it's top left on the screen. So it's just the continuous growth of normal air traffic. So there's continuous growth of normal air traffic, which also requires, and that's a word I will frequently use, transformation. We cannot scale up the current air traffic management system and to cope with ever-increasing demands. So we have a great opportunity here. We have the great opportunity is to have a one-catch-for-all solution. So a few points to summarize some challenges and opportunities or principles. We need, I think that's clear from the previous speakers, a global approach. This is not something you can do on a state-by-state basis. Well, apart from the larger states, of course, there's a need for flexibility, which has also been mentioned several times, and no unnecessary constraints. And especially from a regulatory point of view, this is something we need to take to our hearts. And minimal fragmentation, especially when you have a very dense landscape of air navigation service providers. You cannot do that at that scale. It requires something else. There's a need for integration, and that's a word I would like to emphasize as well. This is not only about new entrants, it's about the whole aviation system, the whole use of air and space and the interaction between it. So with conventional airspace users as well, and that's why I mentioned explicitly also this growth in that sector. And also between new entrants, they need to work together, as we have heard as well. So this bullet comes with a question mark. Do we need a new ATM regime, or do we need to transform the current ATM regime to accommodate also the new entrants? And there are legal issues. I'm not a legal expert. I don't have any ambition to become one, so I will leave that for what it is. So let's have a look at flight phases as a way to see how this can be integrated. And I was pleased to hear the previous presentations, and I think this connects reasonably well to what we have heard so far. So there's a pre-departure phase, a phase to prepare for the launch or takeoff, whatever term you want to use for the vehicle. And then there's a departure and exit phase, exit from, let's say, the conventional airspace into space or the stratosphere or whatever we want to call it. And then the thing that is up there, the vehicle comes back. So let's take these flight phases as a way to look at it. So clearly in the pre-departure phase, departure-exit phase, this is the landscape or the area of responsibility of the air navigation service providers. And for the sake of this presentation, I've called the space responsibility to have called that space traffic management. And this can well be the sort of initiative we have heard about, this collaboration between new entrants to come to solutions between themselves. Important, and what we should not forget, is that we also need an enabling infrastructure. And this is, we need to communicate, we need to survey, we need to navigate. Also want to stress the point that we should not only look at the system today or the new entrants as of today, it should be scalable and future-proof. Maybe there will be new entrants in 10, 20 years, and you don't want to have a dead-end situation. This can be in the future a vehicle that starts in UTM as an autonomous vehicle, then go to controlled airspace, and then go up to the stratosphere, and all that needs to work together. So let's look at the typical, let's say, ANSP task. So pre-departure, there's a need to share and negotiate the trajectory, the intent of the flight, from the entry, from the departure to the exit point. While the aircraft, the vehicle is in flight, progress needs to be monitored. The typical ANSP functions, separation services may be there, may also be solved strategically. Alerting service, I also want to mention that. If there are people on board, of course, it is an important service that need to be fulfilled. When the vehicle returns, there's the opposite direction, flight monitoring, if necessary, separation services and alerting services. During the space flight, of course, there should be awareness. This entry point, the time and position need to be monitored, and if that is diverting from plan, there's a chance to act. If you look at the space traffic management functionality, also there's a need to take part in the negotiation of the trajectory, of the intent. That's a collaborative process. It's a word in this building that we are using more and more, collaboration, collaborative decision making. This typically is part of collaborative decision making. So this intent is shared and agreed, and depends on the type of operation, whether there's a need to deconflict the trajectory before departure, or whether there's still maneuverability of the vehicle when it has departed. During the departure and exit phase, it needs to be monitored on this entry point into space, and of course during the space phase it's needed to monitor flight progress, and also there's if people are involved, and alerting service, but also without people, if you have an unexpected abortion of flight, you need to see where it lands. So these are, let's say, typical phases of flight and what needs to be done. And again, collaboration is very important. Now we develop in ICAO at the moment, and it was a few weeks ago that I was chairing the ATM Requirements and Performance Panel in this very room. We are finalizing the TBO concept, and TBO stands for Trajectory-Based Operations. And the essence of trajectory-based operation, in a few very simple words, is sharing of the intent, maintaining the trajectory during the whole flight phase, and making that the basis for collaborative decision-making. That's the essence of trajectory-based operation. If you want to learn more about TBO, there are a few sessions as well during this week where TBO will be further presented in detail. So this is a way to look at how we can collaborate. So a few points on this, a bit repeating and summarizing. So in the strategic and pre-departure phase, we share the intent, we negotiate the trajectory, and I deliberately put some abbreviation there, not to impress you, but just to give evidence of work that already is taking place. SWIM, Swiss System-Wide Information Management, FFIs, Flight and Flow Information for Collaborative Environment, and FIXM is the Flight Information Exchange Models. Now these are not paper animals, these are real things. FIXM is something that has been implemented, it's being used in experimental environments, and this is ideally an environment that can embrace and should embrace also the new entrants. During the execution phase, monitoring the progress of the agreed trajectory, precise and update that, and also this phase can be and should be supported by SWIM, FFIs and FIXM. So what I want to say with this is that we are not starting from scratch. We're not starting at a 0 point. There are things out there and we need to embrace and include the new entrants in it. Emergency, contingency and re-entry scenarios also need to be developed. So what does that mean? If we integrate new entrants in trajectory-based operation, is that we need use cases, we need to develop it, we need to identify the information that needs to be exchanged, we need to identify the decision-making processes. So this is not rocket science, it can be done. So, in summary, trajectory-based operation, through that we are already working on the transformation of air traffic management. It can and should embrace new entrants. And the picture I'm going to show is not a new entrant, but it's very used to transformation. And with that, I would like to thank you.
Thank you. Thank you, Henk. And I have a special thank you to Henk. We go back a little bit of ways. When we had the terrible incident of MH370, I called Henk and said, could you come in and help us figure out a way to track aircraft in a way that's supportive for the future, and he agreed to chair a group and work just tirelessly over a long period of time, and I took my exit before he did, so I just never had the chance to say thank you very much for all that work, personal time that you put into that, and you and the colleagues that work with you, so thank you for that. Okay, so over to you, Dan. You are the last speaker, and as you walk up here, I'll just say a couple things. So what this community is not looking for is 450 and up, the same thing. What you've heard from everybody is some level of autonomy, and in order for them to get that, they have to work together to put together a safety case and to figure out how they're going to work with each other and present to you, the aviation community, that in fact what they're proposing is safe. So over to you, Dan, and get your questions ready. They're all going to remain up here. I know you have questions. You approached me at the break. So get your questions ready for after Dan.
Thank you, Nancy. And I do have to agree with you that I don't like the word disruptor either. It was a word used frequently on my report cards every year in school. I've spent my adult life trying to channel that disruptive tendency in me to a more positive mean, so thank you for bringing that up and revisiting my childhood. I'm thrilled to be here. Thank you for having me. It's really been a great opportunity for us, as this it feels like a very new topic, but it really isn't. It's actually, as we said, this panel has proven that it's not new at all. The challenge for us is anytime when ANSP faces these kind of challenges, trying to decide when to engage can be a little bit hard to figure out. But we're here today to say we are actively exploring this. It's something that we've become aware of, that we realize that we cannot afford to wait any longer to really dive deep into this area and try to work collaboratively with the world community to figure out a solution. I think earlier all the panelists have already proven the need to you that this is time for us to be addressed. We don't want to revisit what happened with the small UASs where we were pretty much caught flat-footed, and for us, we're not necessarily nimble, is not a word that we often use with the government. But this is an opportunity for us. It's an opportunity to take this on, to look at it and work together and come up with something really good. You know, there's never really been a strong push before. I remember I started my career in the FAA as the air traffic controller. I was the en route controller in the middle of the country. And I remember one day, many, many years ago, Learjet came on frequency. It was in the morning. It was at flight level 490. You hardly ever saw anyone that high. And he wanted to go, he requested wrong for direction at 510. And I paused. I was like, wow, that's impressive. I think they were just trying to see if they could do it. And I waited for a moment, and I came back and said, unable due to traffic. And there was another pause on his. He probably thought, okay, is this guy for real? And he never answered me. I think they were like looking at each other in the cockpit going, did he just say for traffic? And I come back, no, I'm just kidding. Actually, yeah, no problem. There's nobody there. And actually, I've never seen anyone civil at 510 before, and I've never seen one since. So even though that was probably many, many years ago, it hasn't really changed. But it's changing now, but with different kinds of aircraft, vehicles. So there was a need. We demonstrated a true need to create a safe, scalable, affordable, equitable, accessible upper E airspace for current as well as new entrants. It was fun just looking through the slideshows of the industry folks and seeing what they have planned, but you know there's a lot more coming. So one of the challenges that we have, though, is our current upper E airspace. The regulations that we have were predicated on traditional airspace usage and do not address the technical, economic, or political challenges for the operational diversity envisioned above flight level 600. Now that was a mouthful. That's really all to say. Can you imagine the people that wrote our regulations, when they wrote them, had any possible idea of the slideshows you saw today? I don't think so. I mean, we look at some of the things that have been written, and it's obviously they were written for the time they were written in, and those aren't going to work. They absolutely just do not work. They're not going to fit. So we have new users emerging. We've already seen this, a wide variety of vehicles, everything from balloons to boom. I mean, everything in between. I love that too. I just want to say that a lot. It's just boom. That's really great marketing. And so then the also thing we find out is the vehicle characteristics vary widely. So as an air traffic controller, you know, one of the things that makes our jobs more manageable is that the discrepancy between performance are not really that big. We segment airspace for that. We have high altitude airspace. You know, mainly you're dealing with commercial aviation. They're all going fairly fast. Sometimes you have some outliers, but this is a different ballgame. This is totally different. Another challenge we have is the forecasts are uncertain. We really don't know for sure what to expect, how to plan properly. And then finally, our current infrastructure does not support full operations above flight level 600. Now, if you went out and you talked to air traffic controllers, yes, we do have a stereotype, and yes, most of the time it's true. If you went out and talked to them, they go, yeah, bring it on, man. We'll just raise the ceiling. We can handle it. You know, just throw whatever you want at us. Well, that's not going to work. So this is a picture of so I don't have any cool videos, and I'm also the last speaker, but I'm going to do the best I can. So this is a picture of a balloon, just kind of loitering, doing his thing, providing internet service, whatever they're doing, collecting data. And you have a boom aircraft going to come through there at Mach 2.2. Now, in normal air traffic, you're dealing with aircraft that go 6, 7, 8 miles a minute. I can handle that. Not a problem. But an aircraft that's doing 45 to 50 kilometers a minute, I don't know. That's not going to work. So how in the world, in a tactical situation, in a tactical way where you're relying on someone to intercede and issue control instructions for a potential conflict, How in the world does that translate into our current environment? It just doesn't. I'd have to know about this situation hundreds of miles away. And as you heard earlier, I just can't say, turn 20 right for traffic. That doesn't work. So in a situation like this has to be known well in advance and handled in a very discreet and as a small, intrusive way as possible. There's just no way that's going to work. We see how hard it is in our current environment. I remember a Twin Cheyenne at flight level 280, and it barely doing 240 knots, and right in the middle of all this civil aviation, all these commercial airliners trying to descend. It was horrible. I had like a 200 knot difference in the aircraft. I thought that was bad. You're talking about basically a stationary object and Mach 2.2. That's not going to work too well. Well, what about two supersonics? Now we've just doubled the area that I have to know about to be able to handle this. So anyway, as you can see, there's some real challenges to this. So even if we did have infrastructure, the surveillance, navigation, and comm, be able to do this actually demands a different response. We have to figure out what is the real challenge that we're facing, what is the real problem, and we offer opportunity then to create a clean slate approach to this. Let's actually solve the problem that we have. And again, this is a very different situation that we're dealing with. This slide just shows some of the variants. We have, commercial space that's also going to be going through this mission space. Probably more in a vertical, just punching up through and coming back down. But we also know that there are also some other very interesting platforms out there that do not follow the traditional trajectories. They may do more of arcs, not so much straight vertical. And you've got everything in between. So a lot of challenges. Some good things about this kind of airspace is we have known participants. It's not like, so I also worked in the UAS arena, and it's the difficult challenges of how do you solve that dilemma, because especially in the ultra-low airspace, you have not just small UASs, but you also have especially in uncontrolled areas, you've got the pilots that have no equipage on board. We still have some of those. You have helicopters who are doing missions in very non-traditional spaces, whether it's meta flights, landing in a field next to a highway. You've got all kinds of one-off situations, crop dusters and all these things. Really, really hard challenges. We don't have that here. The people that are operating in this airspace are people that have had to pay the price to get there. They're very smart, they're very well educated, they're just very knowledgeable about what it takes to be able to even get up in this space requires a very high level of sophistication and advanced technology. And what we're seeing is industry is actually helping us figure this out. So that's another thing that excites me on the FAA is that, we're not sitting down and trying to decide with EUROCONTROL, okay, what do we do to fix this? We're sitting down with industry and really being able to understand what are the challenges, what are the different mission profiles, how do we actually come up with a system that makes sense? You've heard a lot about already what that's going to look like. I won't spend a lot of time and be redundant. But again, cooperative, it has to be cooperative, has to be performance-based, where intent is shared. Where everyone says where they're going to be, a trajectory-based, as Henk was saying. It's got to be a concept that's not going to burden the ANSPs. We all have our constraints. We can't just levy a bunch of whole new stuff on all ANSPs. We have to figure out a way to do this smartly. There has to be common principles. I think you've heard over and over, this is not a U.S. problem. This is not a EUROCONTROL problem. I shouldn't say problem. It's not a U.S. opportunity. It's not just a EUROCONTROL. It's a global challenge. Because these operators who are going up, as you've seen, when they go up there to fly or loiter or boom through the airspace, they're not just hanging out over Indianapolis. Or they're going all over the globe. And it's just going to require a different approach. And then finally, this is a phrase that PK from NASA uses. If you know PK, it actually applies to UTM, which is the system that's being developed for 400 feet and below in the U.S. on how to manage kind of a self-managing space for small UASs. But flexibility where possible and structure where necessary, which is actually the inverse of the traditional legacy airspace we have, and for good reason. We have a highly structured environment that has served us very, very well. We're really, really good at separating aircraft and providing service. But this airspace that we're talking about is a whole different ballgame. So I'll just close with this. Peter Drucker said, the best way to predict the future is to create it. I believe that we have an opportunity to create the future. Thanks.
Sorry, no, take your legs off. Okay, thanks, Dan. Thanks very much. So let me just take a quick summary. So what you heard today is, in general, the demand that's out there in terms of the needs. I ran through the numbers one more time. Just in the missions associated with the internet and telecommunications, it's a $2.2 trillion business, and just the platforms related to high-altitude platforms are in the neighborhood of $121 billion. So it ain't like this isn't going to happen. It's happening. The question is, how do we respond to that? And the industry is committed to working together to come up with solutions and bring those solutions and proposals to ICAO and to the states that they wish to work with. So I really want to congratulate them for making a commitment to work together. I have to say, in the last few days, they've just met each other. So this is all very new even for them, and they've made a commitment to work together. So I really applaud them for doing that. Now, I know you have questions. Andy? Entrez-vous, huh? So Andy thought he was going to get out of the questions. No. All right, so we're ready for your questions, and for any of them, please, just raise your hand, and then we'll hit your button and take a question. Don't be shy. You won't get this opportunity again. If you don't, I've got questions. Thank you.
Thank you for an excellent and engaging and very timely and relevant presentation. I'm Neal Wolf. I'm with the McGill Institute of AirSpace Law. The concept of an exclusive utilization space is one I'd like to follow up on. If we try to count the number of law journal articles about defining the boundary between air law and space law, by the time we got an accurate count, there would probably be 4 or 5 dozen more. So the idea is attractive because it proposes something new. My question is not whether it's really a great idea. My question is, what do the industry players see as a drawback if bilateral agreements were the place to start? Supposing, and this is completely hypothetical, I don't mean reference to any particular state, but supposing 2 members of the ICAO Council, whether from Part 1 or Part 2 members, decided to enter into a memorandum of agreement for operations above 60,000 feet, and supposing they engaged in a set of operating principles. Would that be a negative toward further development in this area, in your view? Thank you.
Well, as I had mentioned, I prefer to have a multilateral negotiation as the best way. The bilateral negotiation is one of the solutions, but it is not quite perfect solution. And that is why I would like to call in the ICAO and use ICAO as a good platform and to make this happen. Thank you.
Okay, I will. So from my point of view, for the last year or so, that's exactly what Google has been doing, is bilateral discussions, literally country by country by country by country. It can be done. It'll have to be done if there's nothing else, right? But I would say that it would make more sense, particularly for those continents, and there are continents where this type of service is necessary. Africa, for example. Most of the countries around the world, as I said before, have a national requirement to have access to the internet for their citizens. So aviation may very quickly be overtaken by the Ministry of Innovation or the Ministry of Communication, which is pushing aviation to accept this technology to enable the internet for their citizens. So I think that it makes sense to take several parallel paths. Bilateral is what's happening now, so that's going to continue. I think multilateral for those continents where it makes sense and the services are very much needed. And on a global level, I think we need to consider if there's a pathway there. Certainly the more you add, the longer it takes. So I think there's room in parallel for several opportunities.
Okay, thank you very much, Madam Graham, and thank you for the presentations that we've had so far during the course of the day. When I looked at the balloons, that Project Loon, the Aquila, and Airbus, that is called the Stratobus, and the rest, and then came the boom. My question was similar to the last presenter's question. How do we address the occupation of the boom and all these low kind of projects within the upper airspace? And when I looked at it, my thought went to the separation and airspace safety panel, where we normally sit, and I was, wow, this is a very momentous task. But like we said, history normally gives us a lot of thought. And I don't know if the same thought is the one they're also sharing when it comes to accommodating the boom and the rest in the stratosphere. In that, in history, we created some kind of corridors for specific flights and segregated the slow-moving or unconventional kind of traffic into an airspace where we thought, okay, let them be in uncontrolled airspace and let the special aircraft be in a particular space. I don't know if that is the concept they are going to use, or do they have any other solution, because tactical separation is out of the question.
Yeah, kind of. I think really the point that Henk made earlier on, that these days we have so much information management capability that in fact you could manage volumes of airspace and trajectory-based separation in a relatively tactical way, unlike perhaps some of the inhibitions that we have hitherto had. So I don't have any difficulty with the concept of booking my bit of airspace that I want to operate in today or this afternoon, and then potentially even negotiating when he comes smashing through at warp factor 9 in order to maintain separation. I think, though, the granularity of that tactical management is actually much bigger than what we're used to in standard sort of IFR scenario. And therefore, it really ought to be possible to accommodate that, even with the generous separation margins that I think we would agree would make sense. So I think it comes back to the common theme that we've had all through this afternoon's presentations about being trusted to declare your intent, to doing that in a coherent way, such that we can then possibly through some central brokerage, and I don't quite know how that might work, make sure that this sort of tactical separation can actually be achieved. So I wouldn't promote hard segregated airspace boundaries. I don't think that's necessary. I think some more flexible concept that we can work together to develop is absolutely the solution.
Let me add a thought to that and just say that I think maybe early on that's a possibility if it's necessary. But the machines are going to have to talk to the machines and work it out. This is not something that's going to be managed from the ground. There will always be a human in the loop, but the machines are going to have to talk to the machines. And that freaks us out a little bit as aviation people. But look at ACAS. Machines talk to the machines, and it works better. Look, we've never had another Uberlingen. It works better. So we have to get past that what we feel in our gut and to the science of what actually is working. So you've got automated cars now, you've got automation at the lower airspace, now automation at the upper airspace. There's a lot of commonality in that arena, and creating the safety margins that are going to allow for that to be enabled. It's going to take some time, but we've got to let the machines talk to the machines. Next, please.
Thank you. Thank you for some very good and very enriching presentations, because for the first time I have heard a lot of more requirements. My name is Fran Halle. I'm from the regional office in Paris, and it was really good to listen to the variety of applications that we are facing in the future. I heard for the first time we need a band of 10,000 feet for having this kind of slope during the recharging cycles and the descent, and the non-stationary or the stationary balloons, and the range of radius if you want to change your trajectory and that you have an influence from the wind. That's completely new things to ATC that I'm used to as I was previously controlling aircraft. And then you have the new aircraft coming in with boom that are talking about complete different thing, and I just want to thank the FAA presentation because it was really hitting the point here. How can you tactically try to control and be responsible for something that doesn't move at all versus something that moves with 50 kilometers per minute, and you don't know the trajectory and you don't know the maneuverability of the encounter. So I think coming to my initial remark or question here, I think we have to look into a different regime than we have heard or used before in aviation. And I take the presentation from Professor Liu. We have a similar thing already when we look into the seas. We have UN clause, and we have even in the high seas rowing boats operating with high-speed military boats with commercial cargo operations. And they're not hitting each other because they have a treaty somewhere in place where they're accepting individual responsibility for collision avoidance. And we have the same in the space treaty because the millions of satellites that are flying are also not hitting each other. So maybe there's something to think about in a less regulative approach, but more in a more treaty approach that would also then solve the issue on sovereignty, rights of overflights, rights of passage. I think this presentation was also very helpful to maybe put something up that is fit for the purpose, for the variety of applications that we have heard today. Thank you.
Thank you. So it's a very interesting presentation because everybody seems to be coming to the same conclusions, that we need a different concept of operations for separation in that space that is not like tactical separation. And one of the things that I saw come up throughout the themes was this, that bilateral agreements are the more difficult process. And when we talk about these types of operations, they are more global operations, which took me back to the 1950 Havana Agreement, where ICAO brokered an understanding amongst states in the Caribbean and North America that allowed the countries to delegate the service provision over their sovereign airspace to other states. And this was an ability for those states to say, we don't actually have the capacity or interest to provide services above a certain altitude, but we don't want to relinquish the sovereignty of our airspace. Do you envision ICAO playing a role where maybe 2, 3, or 10 large states that do control airspace above 45 or 60 today would be able to provide that services on a more global basis with the concurrence of the underlying states to address that sovereignty versus service provision question? Because I believe there's no limitation on a state's ability to allow another entity to provide that service. It doesn't compromise their sovereignty. So do you see that in the future?
Well, you're correct. There's nothing that would inhibit that. It certainly is in the framework of possibility. It's also in the framework of difficult. So I would say that not in the early days, because I don't think there's enough recognition or awareness or demand. I think that in the early days, we're going to need to see some trials and some building confidence in what these craft are and what they do, and they don't bang into each other, and the machine-to-machine will work. But I definitely can see where there may be an overall half a dozen service providers around the world that are really just monitoring for off-nominals, for things that are not normal, and then guide and enter the human when you have the off-nominals. I could definitely see that. And certainly ICAO can facilitate that if there's a will by the states that are underlying. Anybody else want to tackle that? Sure.
According to the characteristics of the EUS, it has nothing, it have no connection with the sovereignty. So since it is not territory airspace, that is possible to designate it the services, no matter it is still a traditional air traffic management service. So that is possible to have several countries work together to provide the service to the near space, or we call it the EUS. But we need multilateral agreement, or at least we need some guidance for this part.
Good afternoon, Paul Adamson from ICAO Secretariat. Thank you very much for the interesting presentations. During the presentations, particularly the balloon and airship operators talked a lot about the launching, but I'm kind of interested in the recovery, the accuracy of the recovery process, and do you recover the balloons and the airships, and or do they somehow land somewhere where they might not be recoverable? Do you have a lot of control over that process?
Alastair, maybe you want to go first, and others can pick up.
So the short answer is we do recover our balloons. We've learned since we've been operating since 2012 how to manage where they're going to come down. We have designated recovery areas with recovery teams under contract in all those areas. When we're going to bring a balloon down, we coordinate with a local ATC, say it's coming down, so they're aware that it's coming out of FL 600 or 610 or whatever. And we tell them where it's going to be coming down. We target a zone of about 50 kilometers, give or take. And then when they say you're clear to come down, we make the decision, we cut the balloon, and then it comes down in a parachute and lands in the designated area, and we pick it up. Sometimes it's taken us longer to get them than we are desired, such as it gets caught in trees or it's up a mountain slope, but we go get all of them.
Yeah, so at WorldView, we're still in a research and development phase, but we do, of course, recover all our material. Different or separate to the Loon ConOps for that termination, we separate the lift balloon from the Stratocraft itself. The Stratocraft comes down under a steered parafoil. But prior to the termination, that is in coordination with the relevant center. We agree on the time and the location. And once we've confirmed, and this is for nominal events, of course, once we've confirmed that we're good to go, that will begin that termination. The parafoil steers to a pre-identified landing site, and we're getting better and better at actually hitting that landing site, and we're introducing some autonomous steering in the vehicle such that it doesn't require a controller to have a line of sight with the vehicle, and it will actually steer itself to a known waypoint. The balloon carcass comes down separately and at a different rate. It's not under parachute, it just descends itself, and then depending on the terrain that we have brought the carcass and the vehicle down into, will then affect recovery, usually by land, by vehicle, tracked vehicle, or just conventional trucks, and if necessary, we'll use a helicopter to extract.
Yeah, Are we good? Hello? Yeah. Okay. Yes, regarding the Stratobus, the idea is that the full airship will come back to its airbase station under total control. So that's really our idea, and that we are able to predict the envelope of potential trajectories from the stratosphere down to the airbase, and that's it. So full control way back.
You were asking more about the lighter than air, but I'll give you the answer for Aquila, because even though it's a fixed-wing aircraft, it is somewhat unconventional. While we land at a time and place of our choosing, more or less conventionally, we are, one of the reasons we seek to avoid normal airports is that after we land, the aircraft will occupy the runway for a significant amount of time because it can't taxi. So it has to be picked up by some piece of ground support equipment and then taken to its hangar. So if you can imagine the annoyance that this would impose upon the other users of the airport if it was a conventional airport. The other difference that I think regulators and ANSPs would want to know is aircraft like these, both the lighter than air and Aquila, are extremely sensitive to wind and weather in general. For example, we don't want to fly through rain or even cloud. The good news is when you have an aircraft that can stay up for months, you can be selective about the time and place of your landing. So we will extend our flight a few days if necessary, or come down a few days earlier in search of adequate conditions. So in general, we will not be declaring Mayday and insisting on landing right away, and nothing happens fast on aircraft like these. Quite the reverse. You might say, well, we'd rather land in 3 days, not today, just to avoid a storm that's moving through or some such. Thank you.
While you think of yours, I frequently get asked, you know these guys are spying on us. They've got all kinds of spy stuff on these things, don't they? Do you have military payloads on your civil projects? Come on, tell the truth.
Facebook does not. In fact, while we use cameras during flight tests for engineering purposes, the production aircraft has no need for any video or photo device.
Likewise, when we're doing test flights in the U.S., we occasionally fly our cameras for our own information purposes, but when we're flying a pre-commercial or a flight outside the U.S., we never, ever fly camera equipment or surveillance equipment of any type.
Zephyr is dual-use technology. For civil applications, we would carry whatever payload the customer wants us to carry. If that involves surveillance, that would be at the behest of the customer doing a legitimate above-board role, be it monitoring for wildfires or whatever that may be. So yes, it is conceivable that surveillance payloads would be carried, but not for any sort of vicarious reasons, if you like. There would be a very specific reason for it, and it would be out in the open.
At the request from the government.
Absolutely right, and that's no different to any other air surveillance platform or any other air platform, from that matter.
Etienne?
Sorry, yeah, I would share exactly the same answer. It's a dual-type payload. We make satellites the same way. No, I mean, we will put the payload demanded by the customer, that's it.
So another question I get asked periodically is, tell us more about the health checks on board, the technology on board the craft itself. And maybe, Alastair, you could talk a little bit about the amount of information that you get off of the balloon that gives you indications of the health of the balloon so that you can plan for the appropriate landing.
There we go. Sure. We run a complete avionics suite on every one of our balloons that we fly. Simple things like temperature, gas, lift gas pressure and quantity, plus the status of the power system, the status of the communication system or whatever. So we constantly monitor that. If we're providing service, we have a thick downlink to a ground station. We can get anything we want off it. If we're out of a service region and no ground station is in range, we have the redundant satellite control links where we can get the nominal flight information at all times. So we have a good good read on the relative health of the vehicle at any time. If there's something that's not safe or something that means the aircraft's the vehicle's no longer useful, we'll plan a termination in coordination with ATC.
That's actually a bit of an inside joke. I think I'm the only person at Facebook who says it Aquila, probably because Spanish is my mother tongue and it's Aguila, but the CEO says Aquila, so I lost that battle.
You're CEO today, so.
Right, exactly. I just got promoted twice in one day. One of the reasons we seek to keep Aquila up for at least 90 days, and that really is a minimum, is that an aircraft that is airborne is not being maintained, and that lowers the hourly operating cost. But you all know what that's like. 90 days is 2,000 hours, and that is a fairly long time for a UAV, well, for any aircraft, to be maintenance-free. So I think of it as an engineering challenge for our team to make an aircraft that can operate safely and reliably for 2,000 hours without any wrench turning or any parts being replaced. That does not mean it won't suffer failures, it just means it won't suffer debilitating failures. And if you do the math, you end up with some interesting answers. For the aircraft to make economic sense, some of the components cannot be merely triplex redundant like they are on many aircraft. Some have to be quadruplex, which are hard to find. We will have some bespoke components. So in general, reliability and redundancy are a big part of making an aircraft like this for both economic and good, what I call good neighbor reasons. Economically, it simply has to be possible to operate these aircraft for many, many months without too much human intervention. And the good neighbor reason is, you can imagine if I go to your country and say, I'm going to provide internet service, but several times per day, one of our aircraft is declaring an emergency and insisting on an immediate descent. We will not be welcome for long. So part of being a good neighbor is accepting that even though the airspace where we operate might be lightly occupied, there may be severely occupied airspace between us and our airfield. So we have to be able to request a descent and be told, not until tonight or not until tomorrow. And the aircraft has to keep itself safe and not necessarily keep providing internet, but it must not demand an immediate return to base, even in the face of some significant failures.
All of the above, basically. In addition to that, the capability to model in real time the behavior of the vehicle when it has been subject to some sort of failure, which allows us to predict exactly what it's going to do and take account of whatever environment it's going to find itself in.
Yeah, so we fly an ever-increasing number of sensors on our Stratolite, from understanding the differential pressures in the ballast tanks to the temperatures, skin temperature, performance of all parts of the avionics. We too rely on both the line of sight and two forms of satellite communication to the vehicle. We've worked out that we believe that we can enter, so I don't want to say inherently safe conditions, but safer conditions where we will remain above FL600 until such time as we may need to elect to come down. So, echoing the rest of the panel here, we very much working, in collaboration with the air traffic, air navigation service providers, but in terms of our choosing of when to end that flight and even begin it, and we think that's going to continue to be very important.
Just one last word. One of the things to remember is companies like Facebook and Google are fundamentally software companies, and we're very good at processing big data sets. So by the time these aircraft are fully deployed, there will be many of them flying for many, many hours per year. And we will, our algorithms will be able to detect some failures before they become emergencies, hopefully to the point that we say, yes, that 90-day flight can be stretched to 100 days or 120 days because the probability of failures are X. So the extracting knowledge from big data sets is very much the stock and trade of companies like Facebook and Google. And we can extend that to over a period of a very small number of years. We can exploit that to generate this kind of health and utilization monitoring systems that an airline might take a little longer to develop. Oh, hang on.
That was very sweetly said. Let me say it differently. They got more stuff than they have on a regular airplane today that's coming off in terms of, without giving away any trade secrets, they got a lot of information coming off these things that allow them to have the flexibility that we don't have when you have people on board. Please.
So I'm Patrick June. I'm with Transport Canada, speaking as sort of a regulator. And I've listened to the presentations today, and one of the things that strikes me is that we're talking here about sort of a commercial application. We're really changing the utilization of airspace. If we look at historically, we're talking about, if you go back 50 years, a very small number of operators. That's grown over time. We've seen the commercialization of certain things, so going from national carriers to commercial carriers. But in the paradigm we're in today, we're still talking at the end of the day of a relatively, I hesitate to say this, but low volume in sort of the grand scheme of things. And we're talking about apparatus that cost hundreds of millions of dollars, each and every single one. And now, when I'm listening to the speaker speak today, we're talking about a very different sort of scenario where we're talking about commercial applications for telecommunications, for linking people together, for weather monitoring, you name it, it's there. And we're talking about transporting these things up at a much lower cost. And so I sort of think out 20 years to this technology and see the application and see, yes, they go up slowly and they live in this very high space or they come back down. But we've got a lot of companies competing and at a price point that is far more favorable than, say, lifting up a plane. We're talking about the potential for a proliferation and a very high volume of these things. And I guess my question is recognizing that there's a lot of work being done on that already on the air traffic control side. For those like Loon and for Facebook and Airbus and the other groups that have operated these things, I'm curious to know, have you had any sort of experiences both in the ascent and descent phase, so as you're traversing sort of the busier areas of the flight spaces, or even up in the air when Loon is sort of moving these things through the air currents, have you had near misses? Have you lost contact? Have you had close calls? And sort of how did those pan out? And it's early days, so the answer might be no, we haven't seen any yet, but I would be curious if there are any anecdotes, especially in the early days, to share. Thank you.
One of the main reasons we put redundant comm systems on is to avoid that very scenario. When we first started flying, it was a single point of contact, and we put a failure mechanism in the system. As Martin was referencing from Facebook, we have a massive amount of compute power and information to understand what's going on. So one of the things that we wanted to make sure early on when we had a single point of contact on the satellite links is if we lost communication, what would we do? We're fortunate that we never had to execute any of those protocols, but we then went and made those systems further redundant. So we've had no severe situations, and we hope we never do, obviously, but we do everything we possibly can think of to make it safer and safer and safer. And that's one of the things that we've learned with now 700,000 hours. And that doesn't mean we're done. We'll continue to invest in that dimension.
But I take your point that one of the things that we as a community, if I consider this a community of new entrants, not just these guys, but the lower airspace guys as well, have to be responsible for that and responsible for keeping that data and being very transparent about that data. And that includes incident data that can be continually analyzed. I can just tell you, working with these guys, these guys as a community, that's their DNA. So in principle, they're all of them are very sensitive to that. And they all know, just like in the UAV world, one major incident, you're done. So they're all very sensitive to that. Please.
Hello, my name is Oscar Garcia. I'm the chairman of Interflight Global Corporation in the US. And this question is for the whole panel, but I'd like to break it down into Boom and everybody else. we are consultants and we're always facing challenges and opportunities, but a good way to quantify what's ahead is usually to forecast a little bit of, but as a segue to the question before, the volumes. How many units are we looking at in a steady state, in a growth state, if the persistent surveillance were to cover the world, or if the boom aircraft were to succeed as planned? How many vehicles are we crystal balling into the relatively quiet stratosphere? I think if we, even though I'm not looking for a precise number, but an order of magnitude could be very helpful for both the regulators, ICAO, and also the industry looking in.
Sure, happy to take that. So for boom, the sort of projections for the first model of airliner is 1,000 to 2,000 units in the first 10 years after entry into service. So, you know, a modest fraction of the global aviation fleet. You know, in the long run, we have much bigger plans. I mean, we think there's a path to make supersonic air travel as affordable as today's economy class, right? And if that's the case, we're gonna, you know, supersonics are gonna take over the whole long haul market. So many thousands, but you know, sort of comparable to today's aviation fleet.
That's a really tough question. Thousands. How many thousands? Really don't know.
Thousands in the next 5 years? No. Thousands in the next 10 years?
Yes.
What I'm trying to get at is if you look at the aircraft ecosystem, anything that flies in the planet does not exceed 500,000 units, and that's everything. But if you look at drones, and we are already over a couple of million, I'm projecting 7 million of them. I'm trying to get a flavor for, you know, for perspective of not an accurate number, but are we talking about tens of thousands, hundreds of thousands, thousands?
It certainly won't be tens of thousands. At any given time, I'd expect to have several hundred airborne providing service. How many you actually have to build to populate that is a different matter. But also just think of the cost. The reason there's so many hundreds of thousands of little quadcopter drones is because they cost less than $1,000. That's not the case for the kind of aircraft we're talking about. They're quite a bit more expensive than that, and therefore they'll be fewer in number.
What'd you say, Andy? It was a difficult question. It's difficult to predict. It's a huge function of market demand. A vehicle is how we provide the connectivity or lift the vehicle up to provide connectivity. If we have as much success as we're planning for and enjoy, you know, that obviously is going to expand it. But if you look at what we did in Peru, you look at what we did in Puerto Rico, that was a handful of vehicles. So, you know, the numbers are relatively small, but whether it's hundreds or thousands at this point in time, I can't say.
Etienne, you want to take a crack at that?
Okay, here we go. We would be looking at, for the future 10 years, some hundreds to thousands maybe, and that's it for now. It's hard to make any other prediction. These machines, though they are way cheaper than satellites, are still pretty expensive, and it also depends on what kind of payload you want to put on it. I mean, there are many options. It's hard to predict, but we'd be already pretty happy with hundreds of them, I guess. So that's where we stand now.
Yeah, so well, we're seeing it in a similar way in that it's a well for us. I mentioned we're still in research and development, and looking to probably have no more than say 50 flights next year, but begin serious production from there into the hundreds. I think if you spoke to Jane, our CEO, she'd say 10,000, 20,000, but that's Jane. Of course, she's going to say that, but realistically, it's going to be in the hundreds, and that's because we're talking about persistence. So if you're up there, you don't necessarily need to, send another one up. So that's a key part of the business model. So I guess the least number of platforms we can raise for the highest revenue per unit is, that's the equation.
Well, this is not a legal question. I cannot predict how many operations we will have, but...
promote you, then make you do it? If I promote you, can you... Just guess.
Shouldn't. But, well, if we compare with the small UAS or the UAS operation, we have to know now why the UTM is quite aggressive, which grew so rapidly, because they have routine operation in the future. And now, why we have a less interest or we have a less attention from the public, from the regulator, because we don't have a routine operation. We need more operation which could attract attention from the regulator and international cooperation to make this possible.
So this is pretty exciting. I want to be a bit more getting into the detail. My question to all of you from the panel would be, how much of the traditional air navigation services would you actually need in your operations above 660? I mean, I think we are a little bit as crossroads here, because I listen to all the presenters. They have their own operation control centers. They know what they're doing. They have tons of data that no ACC at the moment has. When I hear from Aquila, they can time the descent based on clouds weather, because they don't like to fly in clouds and rain. How can ACCs and conventional aviation can actually fulfill all those requirements? So my question to all of you is, how much of the traditional air navigation services would you really need for your operations, or do you only need access to airspace?
Because the answer to that is they don't need much. I can do that for everybody, right? Yeah. Okay, so let me just close the session by leaving you as a regulator, a series of regulators, with one thought. So this community is coming to you telling you that they want to work together. They have a unique set of operations to do unique things that are demands by the governments themselves in most cases. And it may be, and this is important, so put your thinking cap on, it may be that in order to allow them to do that, you may need something from them, this new generation, these new guys, to build a piece of the system that is missing today. For example, maybe you need a completely new NOTAM system. So if you're going to have intent, and intent shared, machine to machine, you can't do that today with today's NOTAM system. Maybe you need to demand that that's part of the equation for this community or others, the low community as well, to have the kind of autonomy that they wish to have and that they can demonstrate. So think of it as they're willing to come to the table with some new ideas and some new concepts, and you get to negotiate what it is that you need to have the safety margins that you're responsible for in partnership with the industry. So I leave that to you with a closing thought. Maybe it's not the NOTAM system, but think about what it is that they need to bring to the table as a community that aids the whole of the system in moving forward and providing the best services for the whole of the globe. So with that, I just want to thank all of the presenters for being so very candid and for being willing to share their operations and their plans, and for making for a very interesting afternoon. So please thank them for me. And for you CAAs and ANSPs, you got some work to do, so give it some thought. Enjoy the rest of the sessions.